Hello. In the last lecture, we have derived an solution for the Legendre's equation. So today we are going to start a Legendre's polynomial. Before that, we just take a recap what we have did in the last lecture. So last lecture we have defined the Legendre's equation. Then we have proved two cases. One was m is equals to n. Then the m is equals to minus of n plus 1, and then we have derived the solutions for these two. So now we are going to start a solution, that is we are going to start a Legendre's polynomial, and then how they are being defined and how they are represented. Okay, so let's start. The question in the exam, it could be define Legendre's functions of first kind or derive an expression for the Legendre's polynomials. So we'll just start this. Legendre polynomial. So the Legendre polynomials are being denoted as p of n x. Okay. So we are deriving an expression for the Legendre's function of first kind. So now whatever we will be doing, it is, you can say, define question. If you want to write this question as define the Legendre's function of first kind. Okay, so this thing we are going to learn today. So how we will proceed? First is what we'll determine our Legendre's equation. Then we'll get our series of descending powers of x, and then we will solve this thing forward. Okay, so let's start. Sorry. The Legendre's equation. So our Legendre's equation is 1 minus x square d square y upon dx square minus 2x dy by dx plus n into n plus 1 y is equals to 0. This I'll mark it as equation number 1. Now the solution of the above equation in the series of descending powers of x is y is equals to a naught in the bracket x raised to n minus n of n minus 1 divided by 2n minus 1 into 2 into x of n minus 2 plus n of n minus 1 into multiplication. I will write it here, into, it will be n minus 2 into n minus 3. I'm writing it here down. 2n minus 1, 2n minus 3 into 2 into 4. This whole multiplied with x raised to n minus 4 plus dot 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 higher powers. Okay. So as we know, where the value of a naught is some arbitrary constant. Okay. Now if my n, if n is a positive number, now if my n is a positive integer, so what will happen? It will happen, and also the a naught is 1 into 3 into 5 dot 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 something, say 2n minus 1 upon n factorial. So the above solution, my above solution becomes p of n into x. So it becomes, so that what will happen? P of n into x is equals to 1 into 3 into 5 dot 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 into 2n minus 1 divided by n factorial into all these terms, the back terms, into all these terms. So it will be I'll just write x raised to n minus n of n minus 1 into x raised to n minus 2 divided by 2n minus 1 into 2 plus dot 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 dot. Okay, so we have got an expression for the Legendre polynomial. Now note, now what we have to note is this is a terminating series when n is even. This is a terminating series when n is even. Now it contains 1 by 2 of n plus 1 terms. The last term being, my last term will be minus 1 raised to 1 upon 2 into n of n minus 1 into n minus 2 dot 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 divided by 2n minus 1 into 2n minus 3 dot 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 is going further n plus 1 into 2 into 4 into 6 till n. Okay, this is when it is even. Now when n is odd, this was for even. Now when it is odd, it contains 1 upon 2 in the bracket. Previously 1 upon 2 into n plus 1, but now it's in the bracket n plus 1. Okay, so the terms again, terms and the last term in this case is minus 1, 1 upon 2, n minus 1, n of n minus 1 divided by 2n minus 1 into 2n minus 3, n plus 2 into 2 into 4 into n minus 1 into 3 into 2. Okay, into x. So now, so as a result, Pn, that is the Legendre polynomial, is P of n is a, here in this P of n is called the Legendre's functions of the first kind. Okay, remember that P of nx is the solution of Legendre's solution 1. Solution 1, which is equal to unity when x is equals to 1. Previously it was page number 7, so now it will be page number 7 and this will be page number 8. Yeah, so as we have started this new topic called as Legendre polynomial, define the Legendre's function of first kind. So we have taken the Legendre's equation and then we have solved this further, and then we have substituted the values when n is equals to even. So we have for n is equals to even, we had a term 1 upon 2 n plus 1. Okay, so we have got the solution when n is odd, so we have got the solution this. So we are getting that P of n is a Legendre's function of first kind, and here in this part, hence we have proved. Now we are going to determine the solution for the Legendre's function of the second kind. So let's begin that also. Legendre's function of the second kind, which is denoted as q of n into x. Okay, so for second kind we are using a symbol as q of n into x. Okay, so let's begin. The another solution of Legendre's solution. This is not a big proof, we are just doing the substitution. So Legendre's equation, as we are thorough with this, 1 minus x square d square y upon dx square minus 2x dy by dx plus n plus 1 into y is equals to 0. N is missing here. So when n is a positive number, what will happen when n is a positive number? So my y is equals to a naught of x of minus 1 plus n plus 1 into n plus 2 into x raised to minus n minus 3 plus dot 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 divided by 2 of 2n plus 3. Now if we take a is equals to a naught is equals to n factorial upon 1 into 3 into 5 dot 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 2n plus 1. So what will happen? My above solution in this one, that is x. So it will become q of n of x. It will equals to n factorial upon 1 into 3 into 5 into 2n plus 1, then my whole solution, this one, that is x raised to minus of n minus 1 plus n plus 1 into all this term, whole thing I need to write it as. So it will be n plus 3, n plus 2 multiplied by x raised to minus n minus 3 divided by, this is a multiplied term, okay, see it's I've written I have put dot, divided by 2 of 2n plus 3 whole plus dot dot dot. So higher powers will be in the preceding part. So I hope up till here it is clear what we have done. So the series of q of n into x is a non-terminating series. Now the general solution of the Legendre's equation is, so this is my page number 8. We'll just write the solution, we are not going to give the proof for this. So the general solution of Legendre's equation is, so it is what, y is equals to a of p of n into x plus b of p of n into, it is q of n into x, where this a and b are two arbitrary constants. A and b are two arbitrary constants. I'll just give you the simple form.